Today we're going to go over section 6.2, angles in the unit circle, day 1, where we will talk about angles in standard position and reference angles, and then coterminal angles using that. So what we're going to start with is the idea of standard position. So an angle in standard position is represented by theta. The vertex is at the origin, and the initial side is the positive x-axis. So the initial side of a angle is always located on that positive x-axis. So no matter what the measure of the angle is, if it's in standard position, its initial side, that ray on the right, is on that positive x-axis. The terminal side is the side that moves. So the terminal side is the end of the angle. So the terminal side on this is in the second quadrant. So our terminal side is here. It's the other ray that forms the angle. So what's new based on compared to what you've seen in other math classes is that now we can have positive angles and negative angles. So a positive angle rotates counterclockwise. So from the initial side, it goes up from the x-axis, and that creates the positive angle. Where a negative angle rotates counterclockwise, a negative angle rotates clockwise, so positive counterclockwise, negative goes clockwise, so the negative angle goes down from the initial side and rotates in that direction. So when I'm sketching an angle in standard position, I'm really just starting with the angle with a coordinate plane. So no matter what type of angle I'm sketching, my initial side, I'm always going to start with a line on the positive x-axis. So no matter what measure I have, whether it's positive, negative, anything degrees, radians, it's always going to have that initial side on the positive x-axis. So what I have to think about to be able to sketch this angle is if I'm going around the quadrants, each axis represents 90 degrees. So if the terminal side and initial side were the same, that would represent a 0-degree angle. If I go counterclockwise 90 degrees, it would be on that positive y-axis. If I go counterclockwise 180 degrees, it would be on the negative x-axis. If I go counterclockwise 270 degrees, it would be on the negative y-axis. And then all the way around is 360 degrees. So when I'm identifying where the terminal side lies, I'm thinking about where does it lie between 0 and 90, 90 and 180, 180, 270, 270 and 360 to determine which quadrant I'm in. So again, I just started at 0 and rotated by 90s, right? So I'm adding 90 each time, and that's what each quadrant angle represents. And so if I'm thinking about 220 degrees, that angle is bigger than 180 but smaller than 270. So that angle is going to end in quadrant 3. If I think about 105 degrees is bigger than 90 but smaller than 180, and so that's going to end up over here in quadrant 2. So when I'm looking at a positive angle, I'm thinking about each of those numbers to determine where the terminal side will lie. So the terminal side for 220 degrees is going to lie in quadrant 3. So if this is 180 and that's 270, it's a little bit closer than 180. Then to 180 than it is to 270. So I'm going to draw my terminal side so that it is a little bit closer to that 180 degrees. And so the angle starting at the initial side, rotating counterclockwise towards the terminal side is a positive 220 degree angle. So when I'm drawing a positive angle, I'm going upwards from that initial side. So I want to draw the terminal side for 105 in quadrant 2. Remember that I'm thinking about that this represents 0 degrees and this represents 90 degrees, where this represents 180. And so I know that 105 is going to end up pretty close to 90, way closer to 90 than it is to 180. So this terminal side is going to end up closer to 90. Again, I'm estimating. We are getting out a protractor and measuring. We're just identifying, okay, which quadrant, what is it closest to? We're kind of eyeballing it. So from the initial side towards the terminal side, I always have to draw this arc so that I know what direction the angle is, and I'm going to label the angle measure next to that arc so that I can visualize what does a 105-degree angle look like. What's changed in negative 290 is that because it's negative, that tells us that we're going to rotate this clockwise instead of counterclockwise. So when I lay out my degrees where I'm comparing where does this fit, what two values does it fit between with my 90s, I'm actually going to go the opposite direction. So 0 degrees, I'm going clockwise, so my next would be negative 90 degrees. Okay, so if I went this direction for that corner, that's negative 90 degrees. So then if I add negative 90 to negative 90, that's going to mean that this is going to represent negative 180 degrees. And then if I add negative 90 to negative 180, that's going to represent negative 270 degrees. And then plus negative 90 is going to represent negative 360 degrees. So if it goes all the way around, that's clockwise direction, that's negative 360. So if I think about this now, that's going to change the layout so that my terminal side is not in quadrant 4, like you might assume if we were using the original, if this was a positive angle of positive 290, notice it would end up over here in quadrant 4 next to 270. But since it's a negative angle, we're going the opposite direction. My terminal side is going to be between negative 270 and negative 360, which is actually in quadrant 1. So I'm going to draw my terminal side a little bit closer to 270 than it is to 360. And since it's a negative angle, my arc is going to go the opposite direction. So this is going to represent negative 290 degrees. Okay, so that's drawing an angle in standard position. Using degrees is the most straightforward way to identify where it lies. So if it's not a value that's on the unit circle that we know, I would just convert it to degrees because it's easier to kind of think about those references. So for example 4, when they're giving us angles in radians, that's what we'll start with. Let's convert them each to degrees. So if I'm converting 4 pi over 3 to degrees, I'm going to multiply that by 180 degrees over pi. And remember that this idea is that the pi should reduce away so that we have 4 over 3 times 180. And then I should be able to reduce the 180 with 3. So if I divide 180 by 3, that leaves me with 60. So 4 times 60 is 240 degrees. So that means that 4 pi over 3 is equivalent to 240 degrees. So when I'm identifying where it lies, I'm thinking about it as degrees, but I'm going to label it as radians. So our initial side is on the positive x-axis. Remember that this is 270 degrees. So that means that the 240 is going to lie before that 270. This represents 180. So it's going to be a little bit closer to the 270 than it is the 180. So I'm going to put my terminal side here to estimate 240 degrees. But remember that it was given to us in radians. So in radians, I'm going to label it as that 4 pi over 3. Okay, so I'm going to convert it to degrees first and then draw the angle. So then for B, we've got our initial side always on that positive x-axis. And then we want to convert our negative 2 pi over 7 to degrees by multiplying it by 180 degrees over pi. What happens here, though, is that 180 is not divisible by 7. So I can't just reduce this in my head. I do need to use a calculator. So if I do 2 times 180 is 360, and I divide 360 by 7, that's going to give us about negative 51.4 4 degrees. Remember that these values are really just to tell us which quadrant we lie in. So this was positive, it ended up in quadrant 3, so that's where we drew our terminal side. Since this is a negative angle, I know that's gonna lie between 0 degrees and negative 90 degrees, so that's gonna end up in quadrant 4 visually because it's a negative angle. So negative 51.4 degrees is gonna be a little bit closer to negative 90 than it is to 0. But remember that we were given 2 pi over 7, so we're gonna label it that way. So our angle is going clockwise, so going down from our initial side, negative 2 pi over 7 radians. Okay, so when I'm sketching an angle in standard position, I essentially have 2 things that I need to draw. Well, 3. So the initial side that I draw is always the same, that blue side that I drew for each of these angles. Then I need to use the degree measure and the quadrants, knowing that they increase by 90 degrees each time to determine which quadrant the terminal side is going to end up in. And then I kind of estimate its location. It doesn't need to be perfect. Don't always draw it in the middle every time though. So it needs to be closer to one than the other. Or exactly down the middle if that is true, if it's 45 degrees away from both of them. And then I draw the arc. So if the arc, it goes counterclockwise if the angle is positive, so the green ones that I drew, and then the arc goes clockwise if it's negative, so the red arcs that I drew. So you need those 3 pieces for any diagram. You don't necessarily need to label the degree measures at all. So if you are referring to your notes and you see where it lies just by looking at example 3A and example 3C, because those 2 have all of them, then that's totally sufficient. The next concept in this lesson is reference angles. So reference angles are the acute angles that are formed between the terminal side of an angle and the x-axis when the angle is in standard position. So ultimately, when we're talking about reference angles, we kind of have 4 different situations, and that's all dependent upon which quadrant we're in. So if we're in quadrant 1, the reference angle, the terminal side of the angle is here, and so the reference angle is actually the angle. So if I'm finding the reference angle in quadrant 1, the reference angle is actually whatever angle we're talking about, so those 2 things are equivalent. If I'm in quadrant 2, so if my angle looks like this, then the reference angle is touching the x-axis. And so to identify whatever the value of the reference angle is, I'm going to take 180 degrees minus whatever the angle I'm given is. So the reference angle will be 180 minus theta if theta is in quadrant, terminal side is in quadrant 2. If the terminal side for theta is in quadrant 3, the reference angle attaches to the x-axis on the negative side below. And so to find the value for the reference angle, I'm going to take the angle minus 180. And finally, if the terminal side of the angle is in quadrant 4, the reference angle touches the x-axis there. And so to identify the value of a reference angle, I'm going to take 360 degrees and subtract theta. Okay, so I'm using these formulas to find a reference angle depending on which quadrant theta lies in. So for this first example 2, ultimately I'm identifying really just which quadrant the angle lies in. So if I have an angle of 130 degrees, 130 is between 90 and 180, so that angle is going to end up in quadrant 2. Okay. So I'm thinking about where does this angle lie? If you need to draw the visual of this and label it with, so remember that this is 0 degrees, this is 90 degrees, this is 180, this is 270, and this is 360. That'll kind of help you figure out which quadrant we're in. They give it to you in inequalities here, so both the positives and the negatives. So that's referring to the beginning value and then the ending value between each quadrant. And the good thing about this is it lists positives and negatives. And so 130 is between 90 and 180, so it lies in quadrant 2. So that means I'm going to do 180 minus my angle. Okay. So I'm going to take 180 degrees, and I'm going to subtract 130 degrees from it. One thing to keep in mind is that because of what we're going to do in the next section, we are not allowing calculators on the unit test, so or the next quiz. So you're going to need to be able to do the simple addition and subtraction without using a calculator. So if I'm subtracting two numbers, I'm going to stack, so the number with the bigger absolute values on top, because that one's going to be the sign. So since 180 is larger than 130, my answer is going to be positive, and then I subtract vertically place value by place value. So 0 minus 0 is 0, 8 minus 3 is 5, 1 minus 1 is 0. And so that means that the reference angle for 130 degrees is 50 degrees. So again, the first thing I want to determine is what quadrant this angle lies in. So if I have 210 degrees, 210 is between 180 and 270. So I'm going to be in quadrant 3, which tells me that I'm going to take my angle and subtract 180 from it. So I'm taking 210 and then subtracting 180 degrees. So 210 degrees minus 180 degrees. If I subtract these numbers, 0 minus 0 is 0. I can't subtract 1 minus 8, so I need to borrow from the hundreds place. So 11 minus 8 is going to give us 3. And then 1 minus 1 is 0. So the reference angle for 210 degrees is 30 degrees. So with reference angles, I can be asked two separate things. So when I'm asked to find the reference angle, I'm subtracting from 180 minus my angle if I'm in quadrant 2. I'm subtracting 180 from my angle if I'm in quadrant 3, and I'm subtracting my angle from 360 if I'm in quadrant 4. So that's to determine what the reference angle is. If I'm given the reference angle, I'm going to use essentially the opposite of the formula. So I'm looking for theta, and I know the reference angle. So these formulas are going to change to be kind of backwards if I'm looking for theta. So what's going to happen here is that the reference angle is equal to theta, so that means that theta is still equal to the reference angle. And then if I were to solve this guy for theta, I would add the theta and subtract the reference angle. So this formula is actually technically the same. I'm going to do 180 degrees minus the reference angle. If I'm given the reference angle and I want to find theta, I'm just going to write ref. I'm going to run out of room with the angle part. If I have this formula in quadrant 3 and I wanted to solve for theta, I would have to add 180 to both sides. So that means that if I know the reference angle in quadrant 3, I'm going to do 180 degrees plus the reference angle. And then if I were to solve the equation for quadrant 4, here to essentially, I would have to switch reference angle and theta because they're both negative. So I'd have to add theta and then subtract reference angle. So theta would be equal to 360 degrees minus the reference angle. Okay. So when I am asked to find the possible positive angle measures, those are the values that I'm looking for. Okay, so if I'm in quadrant 1, nothing changes, it's that value. If I'm in quadrant 2, I'm gonna subtract the reference angle from 180. If I'm in quadrant 3, I'm gonna add the reference angle plus 180. And then if I'm in quadrant 4, I'm gonna do 360 minus the reference angle. Okay, so when a question is asking us what are the possible positive measure and negative measure for the angle, we're gonna use the formulas that we wrote down right here just now for the positive angle. So our theta equals the ones that I highlighted in the same color, depending on which quadrant we're in. And so we're gonna start with a quick sketch of the reference angle so we can kind of connect to which, what this looks like. So if I'm given 2 pieces of information in these problems, I am given the value of the reference angle. So they're telling me the reference angle is 45 degrees. So I know I'm going 45 degrees away from the x-axis in quadrant 4. So quadrant 4 is this bottom one. So they're saying that I have an angle whose initial side, remember, is always on this positive x-axis. And it's going around so that its terminal side is 45 degrees away from that positive x-axis. Let me draw this a little bit nicer so that this terminal side ends up with a 45-degree angle next to the positive x-axis. And so in order to find the measure of this angle, we're going to use the formulas in here. So since we're in quadrant 4, theta is equal to 360 degrees minus our reference angle. So if I think about what that positive angle represents visually, it's that I'm taking and I'm going around and then I'm stopping here, okay? And so what the formula means is that it's a full circle minus that 45 degrees, right? It's 45 degrees less than a full circle. So when I'm using that formula that the positive angle is equal to 360 degrees minus the 45 minus the reference angle, visually we can think about that as saying that it's like going around once and then going backwards 45, right? So it's stopping 45 degrees before that full circle. So again, we do have to subtract these on our own without the aid of a calculator. So when I'm subtracting 0 minus 5, I can't, so I need to borrow from the tens place. So if I take 10 away from 60, I have a 5 now, so I've got 10 minus 5 is 5, and then 5 minus 4 is 1, and then 3 minus nothing is 3. So the positive coterminal angle for this is 315 degrees. So that means that 315 degrees represents this positive coterminal angle. So what we have to do for this problem is identify a negative coterminal angle. So what a negative coterminal angle is the angle, let me switch colors so it stands out a little better, is the angle where if I were to go clockwise instead, it's what that angle represents. So the way that we find the negative angle is that we take our positive angle and we subtract 360 degrees from our positive angle. And so again, since we are having to do this without a calculator, when you're stacking numbers, you always put the number with the larger absolute value on top. So even though 360 is negative, when I subtract these, I'm going to do negative 360 first, and then I'm going to add that positive 315. Okay, so I'm thinking about it this way, negative 360 plus 315, so that I can subtract using place value. And so when I subtract 0 minus 5, I can't do that. So I need to borrow from the tens place again. So the 60 is going to turn into a 50 and a 10. So 10 minus 5 is going to give me 5. And then 5 minus 1 is going to give me 4. And then negative 3 plus 3 is 0. But remember, so this side, because the 360 had a larger absolute value, I'm going to have the sign of that. So my negative angle is going to be negative 45 degrees. Okay, so my positive angle with the reference angle of 45 in quadrant 4 is 315 degrees. Its negative counterpart is negative 45 degrees. So that means that in D, when they give us an angle in quadrant 3, we have our initial side as the positive x-axis always. And then it says that our terminal side is in quadrant 3, so we're over here with the reference angle of 20 degrees. So this terminal side is 20 degrees below the x-axis there. So in quadrant 3, when I'm finding my positive angle, I'm taking 180 degrees plus the reference angle. So I'm going to do 180 degrees plus 20. And so when I add those two together, that gives me a positive angle of 200 degrees. And one way to kind of think about that formula, I feel like it's the most intuitive, is that when I'm going around this, I know that when I start, so I've got 90 degrees here, and then 180 degrees here, plus another 20. So that's where that 180 plus 20 comes from. So the 180 represents the that semicircle going across quadrants, right? That's what that 180 is, and then it's 20 degrees more than that. So then when I'm finding the negative, I'm always taking my answer and subtracting 360. So I'm going to do negative 360 plus the 200. And again, because that 360 is negative, I know my answer is going to be negative something, but I'm stacking the one with the large absolute value so that I can just subtract place values. So 0 minus 0 is 0, 6 minus 0 is 6, 3 minus 2 is 1. So the negative counterpart to this is negative 160 degrees. And so visually we can see that that makes sense, right? Because if it's 20 degrees less than going all the way to negative 180. So negative 160. One kind of way that you can check is that the absolute value of the two should add to 360. So if you're concerned about whether your answer is correct, the absolute value of the positive plus the absolute value of the negative should always add to 360 degrees because it's the counterclockwise and the clockwise versions of a full circle. So then the next example is example 1. And again, we kind of went out of order just based on structurally what you knew and what we wanted you to see. And so for this problem, it's very similar to what we just did. So they're giving us a reference angle visually. So in the diagram, we have an angle in standard position and they show us what the reference angle is. And they want us to find the measure of the actual angle. So when I'm finding the positive angle, I'm really doing exactly the same thing that we just did in example 2, C and D, using those formulas. And then to find the negative, I'm doing the exact same thing that we did, which was take our positive value and subtract 360 from it. What's new is that they're asking us for angles that are greater than 360 degrees. So when I have an angle that's greater than 360, what I have to do is actually just add a revolution. So once I find my positive angle, I'm going to then add 360 to that positive value, and that gives me a positive coterminal that has a revolution more than 360. So in theory, I could add 360 a bunch of times and still be true. So it's saying that if I keep going around a million times, right, that's all the same blue angle. What changes is this kind of snail shell shape of what the angle looks like. So in example 1A, we have this diagram where our terminal side's in quadrant 2. So remember that if I think about this, this is 90 degrees. So it's more than 90, but less than 180. And our formula, again, is intuitive. So to find the positive angle, I'm technically using the formulas that we wrote down and used in the last problem. But if we understand enough about these 90-degree increments, we can see that if it's above the line, it's less than that, right? So this positive angle is going to be 180 degrees minus that 45. And again, that is the formula that we wrote down in the previous examples and what we did up here, right? If I'm in quadrant 2, I do 180 minus the reference angle. So without using a formula visually, you can see how that's working, that it's 45 degrees less than 180. So I'm going to subtract 45 from 180. So again, we're stacking because we aren't going to use a calculator on our quiz. So I have to borrow from the 80 to make 70 plus 10. So 10 minus 5 is 5. 70 minus 40 is 30. And then 100 minus nothing is 100. So that means that our positive angle is 135 degrees. So visually, that means that we have this angle here of 135 degrees. To find the negative angle, we're going to take our positive angle and we're going to subtract 360. So remember that we always start with the larger number, whether it's positive or negative. So the number that has the larger absolute value. So negative 360. And then we're going to add that 135 to it. Whoops, not 35, 135. And since they're opposite signs, we're subtracting. Our answer, though, is going to keep the sign of the larger. So our larger has a negative value. So we're going to end up with, when we add these together, negative something. So I have to borrow again because 0, I can't subtract 5. So if I take my 60 and split it up into 50 and 10, 10 minus 5 is 5. 5 minus 3 is 2. So 50 minus 30 is 20. And then negative 3 plus 1 is going to be negative 2. So our negative angle is negative 225. So remember, our trick to make sure that that's correct is we would take the absolute value, so positive 225 plus 135, and we should get 360. So that's your kind of check to make sure that you got the right answer. Okay, so that means that this guy represents negative 225. The new piece is an angle that's greater than 360. So I'm adding a revolution. So visually, what this means is that we are taking the angle that is positive, but it goes around a full circle. So that would be 360 plus the positive angle. Okay. So an angle greater than 360 goes around once and then continues and stops at that angle. Okay. So the way that I figure this out is I take 360 degrees and I add my positive angle. So I'm going to take 135 and add it to 360. So 0 plus 5 is 5, 6 plus 3 is 9, 3 plus 1 is 4. So the angle greater than 360 that is coterminal to the other two angles is positive 495 degrees. So for this last problem, we have a similar picture. So let's go through and find the positive, the negative, and the one that is greater than 360. So again, starting with the positive, let's kind of talk about this more intuitively. The positive angle goes from here to here. So it's this angle where I connect counterclockwise. So this angle would be 90. Plus another 90, this would be 180. And then they're telling me that this is 50. So I'm doing 180 degrees plus 50 degrees, and that'll give me my positive angle. So 0 plus 0 is 0. 8 plus 5 is 13, and then 1 plus 1 is 2. So that means that this angle represents a 230 degree angle. To identify the negative angle, I'm going to take and subtract that from 360. So I'm going to do, or subtract 360 from that value. So remember, for the negative, I'm taking negative 360 and I'm adding my angle that I just got. So plus 230 degrees. So if I subtract that, 0 minus 0 is 0, 6 minus 3 is 3, and then negative 3 plus 2 is negative 1. So I get negative 130 degrees for the negative angle. So what that means is that this angle here, going from the initial side to the terminal side clockwise, is negative 130 degrees. So remember, our checkpoint is, if I think about that as positive 130 plus 230, I should add to get 360. They should add to be a full circle. Our final angle that's greater than 360, we're going to take a positive 360 and add our 230. So we're going to add 360 plus 230. And so that's going to give us 0 plus 0 is 0. 6 plus 3 is 9, 3 plus 2 is 5. So that's going to give us 590 degrees. So that means that this angle where I start and I go around 360 and then I go around the rest represents 590 degrees. So there were a lot of little different concepts. For the assignment today, we're doing on page 313, 18, and then 21 to 34. So that changed. It did say 38 on your notes page, so you're going to need to fix that. And then 43 and 44. So those problems are here. So if you want to pause the video so that students can take a picture, that would be great. I'll leave it so that it stays up for a few seconds so that that can be displayed for the rest of class.